solution consultant with Orion Health. And today I'm going to go into greater detail with FHIR. In fact, I think most of the things that were just said, I'm just going to hash into greater detail. And I think you'll see that we probably share a lot of the same resources. In fact, that sample FHIR message is the exact same sample FHIR message I have in my presentation as well. But the other thing that I think might be somewhat interesting is I'm actually going to show a real-life implementation that we created at the Connect-a-thon in my own integration engine that I have here. Can I get a raise of hands? Who has actually worked with HL7 messaging, been an interface analyst at some point? Okay, so a little bit of it might be a foreign language to some. I think the easiest way to explain it is I would like to compare it to V2 since that's what most of us are working with, and I'll also talk about the differences between V3 and CDA as well. But I think the easiest way is to kind of transition into something that most of us are actually used to working with here. So let me go ahead and start my slideshow here. Great. So the purpose today is obviously to get a very high-level overview of FHIR. I'm going to give you that demonstrable working example. And I'm hoping at the end we have a better idea of what FHIR is and we have enough to get started. So once again, I'm going to ask for a show of hands. It's hard for me to tell because I'm staring into the sun here, but who feels like they have a good grasp of what FHIR is? Good. That's probably more than you would have gotten a week ago. So the first thing I'd like to talk about is what are the drivers? Why are people talking about FHIR? And I have a bit of a different take than I think a lot of people. And in that, I think a lot of what drives anything is money. And I think that the main drivers are coming from three different areas. You've got governments, you've got the vendors, and then you've got the users, the patient providers, et cetera. And I think obviously the government standards are very important. We know that Meaningful Use 3, we're talking about having open APIs, which I'll get into in more detail of how FHIR interacts with that, but FHIR will help move you towards that standard. Obviously, the interoperability requirements are greatly increasing. In order to get to that, to get to this collaborative care, this pop health vision that we all want to do, we're going to have to exchange greater and greater amounts of data, and that data needs to actually be meaningful and useful. I think a lot of times we had problems with V3 messaging, meaning that it was very meaningful, but it wasn't necessarily useful because it was very difficult to understand and very difficult to implement. Whereas V2 messaging, all you really got were messages. It was event-based. We didn't have the ability to exchange documents that could tell entire stories. And this is the kind of information that you're going to need to really be able to pull out, have a good standard around, parse. And once you do that, you have enough information to start doing meaningful things like analytics, predictive analytics, and really being able to do population health how we want to have it done and be able to identify at-risk patients, those kinds of things. And that means that we need a better standard of data to exchange. From a vendor's point of view, we were just talking about how it was used at the library before, but really it's a cross-industry best-of-breed technology. So if you look at different industries, especially some of the more up-and-coming ones like social, Facebook, et cetera, they're using things that are RESTful-based web services for message exchange, and that gives you an API that you have a very, very large user base and developer base out there, so you're going to be able to have more advanced development happening faster because that's the best of breed in other technologies, and we've seen it work in finance and other industries too. So let's go ahead and bring what the best of breed in those ones is into healthcare as well. Obviously, we want to start involving the patient more. It's all about patient-centric care, patient engagement. To do that, you want to have an open API standard. We don't want to have to be preaching to everybody and have a top-down approach of this is how you're going to access your patient data. Let's expose APIs and let the vendors build any type of solution that they want to be able to exchange that data or have the patients be able to access that data or share it how they feel. Excuse me. Obviously, we've got a vast increase amounts in the type and amount of data. So if you're talking about wanting to do analytics, we're going to need tighter ways of actually sharing that data. The CDA version 3 is actually really, really large documents if any of you have dealt with them. Whereas with FHIR, we're talking about a different message standard, and that's going to be simple XML, so it'll look a little similar to what you're used to in v3, or JSON, which is going to be a JavaScript notation. And that's a very, very tight syntax. And what that gives you is a lightweight message standard to share across. And it's ideal for things like mobile devices where you need to have not a lot of superfluous data being sent out, but just the meat of what you need to be able to display things in real time and quickly. Because as you all know, every day we're getting more and more used to having fast access to everything, and you're not going to sit there and stare at your mobile phone for 5 minutes waiting for your patient record to load kind of thing. And lastly, that goes back to the users, the patients, the providers. These are the folks that are going to actually be using it, and regardless of what application and system that they want to be accessing that data from, it needs to be fast. So what I was planning on doing was going through the acronym and asking if everybody knows what FHIR stands, and I was going to throw some toys at people, but since I can't see anything, I think that's probably a bad idea. But I think the key here is F is for fast, right? And it's spelled FHIR, F-H-I-R, so I don't know why all these ridiculous puns keep happening. It's not FHIR, F-I-R-E. But the F is about it being fast, and everybody just talks about, oh, we're going to make it fast. But really, the reality is it's about it being fast to design as well as to implement. So the design is fast in terms of we already have the resources and the objects that we're going to exchange well defined. So that makes it quick for us to be able to design what type of messages that we want to interact with. And then to implement, since we're using an industry standard RESTful web services, it becomes very quick to implement as well, meaning that we're able to go ahead and set up interfaces from systems to systems much faster than we're used to seeing. In fact, I was at the Connect-a-thon in Chicago earlier this year, and we all were tasked with setting up a FHIR interface, and we got it done within a day. So it's absolutely doable. It's all about making sure that every user and end system has the right technology to make sure that happens. Healthcare is obviously why we're here. I is interoperability. We want to make all these systems work together. Obviously, many different types of disparate systems, whether it's a patient portal, a provider portal, all these different types of systems you can be accessed from different types of devices. FHIR doesn't care. We have a standard. We implement it uniformly. I'll talk more about the issue with extensibility and how it was a problem with Z segments, if you're familiar with V2, and how FHIR addresses that so that everybody's implementing the standard in the same way. And finally, R is for resources. This is probably the most complex portion of FHIR, in my opinion, and the one that people have the most trouble wrapping their minds around. But really, they're the building blocks. It's the smallest discrete measure of data that makes sense from a clinical perspective. It's not going to be just sharing random fields or segments or tags. It's about having a patient resource, and that patient has a first name, a last name, those kinds of things that make sense. And all of these are going to be well-defined, meaning that you're always going to be able to know exactly what piece of data you're sharing. They're going to be able to understand it. And when you put these resources together, you can, what I like to say is tell a story, right? We can create a document to let whoever I'm sharing this information about this patient with to tell a story about what's going on rather than it being event-based. The patient was admitted, so now we send one ADT message. Now we can tell a more meaningful story, have more meaningful data. So what I like to do is I like to compare FHIR to the other standards because obviously we're most comfortable with what we're used to seeing. I know that a lot of you haven't actually worked with HL7 messaging or the actual messaging in the interface world itself, but really where we stand is HL7 is obviously the governing body that we're getting most of the information about how we should exchange messages in the healthcare setting. And you can see HL7 V2 started out in 1987, and really that's the one that's taken hold, and probably from a clinical perspective, it's 90% of the messaging that's happening in the States. And they looked in version V3 around 1995. They decided that they wanted to try and make it a little bit more advanced in terms of being able to share documents. So the real difference between V2 and V3 is V2 is always going to be event-based. So a patient is admitted, it generates an admission message. A patient wants, or a provider wants an order for a patient, it generates an order message. A result comes back from a lab, it generates a result message. And really, to be able to understand how all that is going to be interpreted by a provider, they have to have all that messaging coming in. It has to be interpreted by your EMR system. Then the EMR system can explain exactly what's happening, the history of the patient. V3 said, well, let's go ahead and be able to create things like more advanced XML-based. And the V2 is a pipe delimited structure. I think we showed one earlier. It's much, much more lightweight than what V3 is. V3 actually turned into this huge monster in terms of, oh, well, let's be able to create documents, and documents will be able to say, here's all my results history for the patient the last 10 years kind of thing. And that turned into a monster because everybody had their own ways of extending it. You had to have separate namespaces. It was very confusing. V3 never really took off very well in the States, but one aspect of it that did was the CDA, and specifically the continuity of care document, which you're all probably familiar with, and that was around 2005. That's also XML-based message, and the CCD specifically is very useful because if you had something like a referral to a new provider, you'd be able to just exchange the CCD, and it's like a snapshot in time of the health of that patient. You can know their allergies, their prescriptions, et cetera, just from sharing that one document. Around 2011, HL7 got together and they decided they wanted to take a fresh look. This was led by Graham Greaves, and the idea was, you know, what are we doing in the other industries that makes sense, that's more efficient? Why don't we try and use some best practices from other places? And is there a better way of doing this? And what they came up with is FHIR, Fast Healthcare Interoperability Resources. And the idea is the best transmission protocol, the most successful transmission protocol in the other industries is RESTful web services, and the most successful messaging standards have been simple XML, not something that grows into a huge monster, and also JSON, because it has been taking off in a standard as something that can be very well used with mobile, very lightweight, very easy to understand and implement. So what are some of the similarities and differences? V2 is built around reusable chunks of data, meaning that you know that the patient information is always going to be in a PID segment if we're in V2, but you also know that patient information is always going to be in a patient resource if we're in FHIR. It actually is compatible backwards and forwards. V3, they just kept adding, or sorry, V2, they kept adding new versions. You know, version 2.5 would be compatible with version 2.3, meaning they just really just kept adding a whole bunch more fields onto the end. But it was backwards compatible as well as forwards compatible because they shared the same ones. And FHIR is aiming to have that same compatibility. And they had an extensibility mechanism. It was actually quite bad in V2, and I think that's the major knock that anybody who's actually done interfacing in V2 knows, is that you have a Z segment that's great. So you have some kind of information that you want to convey that's not part of the HL7 official standard. And what do? Well, you don't want to start stuffing into random fields. You say, I'm going to create a whole new segment, a whole new line of information, and each field I'm going to define this is this piece of information, that piece of information. And that's great, but the problem is not everybody uses the same Z segment. So you had different end systems sharing Z segments that had the exact same names, but the fields didn't correspond to the same data. Literally, you had no way of knowing what that data was that you were receiving. And for anybody who's worked in the V2 world, we know that it's called a V2 specification, but I like to call it a recommendation because nobody follows it. It is basically out there for people to toy with and let them go ahead and implement it the way they see fit. So the difference is that since each chunk is addressable within FHIR, you always know the context of the patient that you're actually speaking about, that information. It's more than messages. So like we said, V2 is event-based. I'm admitted to the hospital. That triggers an admission message. FHIR can have documents. It can tell stories. It can be a lot more broad and be more meaningful in terms of data. Human readability is required, so we talked about that earlier. What FHIR was looking at is that at a very basic level, if you can read the message that's being sent out, you've achieved some level of interoperability. So every message has to have a human readability factor. The extensions don't collide and they're discoverable. Paul was talking about this earlier, but the idea is that every time you want to extend, you want to convey some more information that doesn't exist in the FHIR standard. It's easy to do through an extensibility mechanism. So if I'm British and I live in London and I want to extend my patient address information to include a flat number, there's going to be a URL, which is going to be a link out to that resource letting you know this is what a flat number means, and everybody will implement that extension the same way, and it'll be easy to come up with that information, to understand what you're exchanging, as opposed to some random Z segment where there's no explanation of what it is, and different people are implementing it the different ways. It's always going to be the same type of implementation. You'll always be able to discover what that extension means. Obviously, the differences are we're going to be using modern tools and skills, so we are moving from TCP, which is the standard for V2 messaging, so that's their transmission protocol. We're now going to be moving into RESTful web services, which is industry standard across many different up-and-coming industries. It's easy to read. The spec is just much lighter. If you ever looked at an HL7 spec, it's just hundreds of pages, especially depending on how many different types of messages they're looking at implementing. So the idea is we've taken what's best in V2 and kept it, but we've just wrapped it around some newer technology to make it faster to implement. V3, I think V3 is probably the least similar of the three options. They're both based on the RIM, the Resource Information Model. They use vocab and ISO data type foundations. If you look at it, you might at first think they're somewhat similar because they are both in XML syntax, but I think, in my opinion, that's really the end of the similarities, other than they look somewhat the same. The model and syntax is so much simpler in FHIR. It's a simple XML. There's not a whole lot of superfluous data. It's much easier to just look at the message and convey exactly what it's trying to do. The names make sense. They're friendly. It's extensible, so we already talked about that, and how you can discover it just by going out to the URL, because that extensible tag will have a URL saying, go to here. This will explain exactly what this extensible feature is. It's going to be compatible backwards and forwards, whereas V3 wasn't. The messages, documents, they all use the same type of syntax, so whether it's an event-based or a document-based message, it's going to still use that same syntax. And we also have brought in JSON, so JavaScript notation, which is going to be some nomenclature that is also lightweight. And if you've done or worked with anybody who's doing mobile development in apps, that kind of thing, JSON is pretty much the standard. So the last one is CDA in FHIR. So as I said before, I think CDA is probably the only portion of version 3 that really took off. And that's because it had some simple types of documents you could exchange, like the continuity of care document. Obviously, they're both human readable. It supports profiling. It has APIs, validation, tooling. Obviously, it has the same similarities and differences as V3 since it's based off the same one. But you still require templates to do any of the CDA message exchange, whereas there are no templates required for FHIR. Obviously, it's not just documents, it's context specific, and this is really important because the thing that's confusing with V3 and CDA is a lot of times if you dig deep into the message, you'll start having information about a person, but you don't understand the context. You have to actually traverse the tree back up to the top to understand that, oh, this information was actually about the patient's mother kind of thing, whereas you're always going to have the context being relayed in that FHIR message at the location that you're at. There are implementer tools out there as well. FHIR is, and I'll share the URL with you later too, but there's a lot of implementer tools to go out there. There's FHIR testing servers to use against. It's a lot more advanced than what you've been seeing if you were doing any kind of IHE message exchange with cross documents and that kind of thing. It's better set up, in my opinion, than what the NIST was, which was kind of an archaic way of being able to test against it. So what is the manifesto? Exactly what are they trying to achieve with FHIR? The idea is that the focus is going to be on implementers. So version 3 had a focus on the modelers, meaning that they came from a good place. They said, we want to convey the most amount of information. Let's create object exchanges that mirror different types of clinical information in a model type of format. But with FHIR, we're looking at implementers, because the reality of the situation is you could convey all the information and make it as beautiful as you want, but if it's not easy to implement, it's not going to take off and it's not going to work. So the first thing is that FHIR needs to be fast to implement and design. The other thing is about targeting for common scenarios. What you'll hear is called the 80% rule. FHIR aims to target 80% of your common healthcare scenarios in the resources and the standards, meaning that all of those are predefined, they're well understood, and you can focus that extra 20% on those uncommon scenarios and the things that actually cause issues, which are things like workflow. Workflow is what I think when you're talking about interfacing is actually what takes the most time to implement. We shouldn't have to be worrying about understanding what a Z segment is. We should at least have the messaging standard down as well as the transmission protocol. Obviously, cross-industry web technologies, we continue talking about that. Human readability. The content is freely available, so there's that HL7 link, which I'll share with you again, where you can go and download all of that information. You can get the resource standards, the documentation, et cetera. There's going to be multiple paradigms and architectures supported, so just like we don't care whether you're coming from a mobile phone, a tablet, a PC, a browser, all of that needs to be supported, meaning that we can speak any kind of language that needs to be able to be relayed for that to be displayed correctly. And we're also going to demonstrate best practice governance, so I'll talk about that a little bit more in a minute here. What's the business case for FHIR? Why should anybody here be interested in actually getting on board? It's simple to understand and access with examples. There's tons of examples. Like I said, the FHIR sample message I'm going to show today is the same sample message that you saw earlier. Those examples exist, and it makes it so much easier to actually create interfaces. Like I said, within a day, we had a FHIR interface working at the Connect-a-thon. The resources are predefined. We don't have to worry about going through and figuring out how we're going to exchange messages. We already know what the standard's going to be. It's developer friendly. XML and JSON is our message standard. HTTP is RESTful Web Service. That's our transmission protocol. Security will be handled through SSL and OAuth. There's a whole set of libraries that are out there for reference implementation. Happy is what we use at Orion. All the paradigms, many clients, many architectures. We don't care if it's a thick client, thin client, mobile, browser, et cetera. We solve the common problems, 80%. Let's concentrate on workflow, what actually is keeping people up at night. There's a very large community for support. I'm actually in a Skype group. If I have a question, I can get an answer to it within minutes, typically. And it's already in use internationally, and I'm very interested to see the later talks where people are actually implementing it. Just to show of hands, does anybody actually have a FHIR interface live, or are they working on designing one right now in their system? Great. So what kind of interchange are you trying to do?
So we're just changing from FHIR, like a FHIR JSON-like interface to pipe right now. So we're just doing a conversion from that and sending the pipe off.
So the downstream system wants a V2 message.
Yeah.
So that's the exact example I'm going to show in a minute here when we get into my interface engine. So I think that'll be really good for you to see. But it's good to hear that people are actually doing some things. I think that the first step is going to be that kind of example, because the downstream systems that you're talking to are still living in the V2 world. So we're going to have to be able to take V2 messages, transform them into FHIR standards, put them into a FHIR server, and then be able to transmit them probably in V2 messages again until people catch up. Obviously, there's interest from providers, vendors, payers, the government, et cetera. The idea is that it results in cheaper, faster deployments that are more reusable. So for a technical overview, I'm going to get into resources now. That's probably the thing that is most confusing. But the idea is that each resource is a discrete unit of data that makes sense from a clinical perspective. You know that there's a patient resource, a problem resource. This is data that actually makes sense to people. And each resource has a base structure of commonality, so it has that extensible mechanism built into it. The profiles for local specific requirements, like that example that I talked about. If you have a flat in London, that's not part of the base resource, but you're able to extend it and let you know that a flat is a way of expressing the apartment number if you're in Europe, for example. Specifications are built like a software product. You're going to be able to automatically generate all of the artifacts and documentation for FHIR. That's part of the requirements for it. It uses the simple XML and JSON. The message standard is smaller. We'll look at a sample message in detail here in a second. All the resources are versioned. It's developed in conjunction with the community, hl7.org/FHIR. I suggest going out there and looking at it for samples if you're thinking about getting into FHIR interfacing. Obviously, connectathons are something that we still have, and we went to the connectathon in Chicago and built out a FHIR interface very quickly. Right now, as we talked about, it's in DSTU. We're thinking it's going to be normative and actually really ready for prime time around 2017. So what are resources? They're small, logically discrete units of exchange that make sense from a clinical perspective. They have a defined behavior and meaning. We know exactly what type of information they're meaning to convey, and we know exactly how they're able to interact with other resources. And I have a graphic here in a minute that'll show how we kind of put resources together to tell a story, meaning that the information that we're sharing electronically now is much more meaningful than just an event of a patient was admitted. We can tell the whole story. There's a known identity location, so they're going to exist in their own FHIR servers where they're going to have everything about them explained. They're the smallest unit of interest in healthcare. You can compare them to kind of like segments in V2. So like a PID segment is all the patient information. You can have a patient resource in FHIR or CMETs in V3. Here's a sample. I'm sure you probably cannot see that very well from back there, but here's a sample of the resources that are out there. Right now, there's 89 resources. They're thinking by the time it goes normative in 2017, there's going to be about 150. So you still have the ability, if you think that there's something out there that should be a resource, you can submit that, and FHIR panel will actually review that. But the idea is that they're broken up into different tiers. So we have a clinical tier within that one, some common ones, you know, a goal, a medication, nutrition information. Those are broken up by clinicals. If you want an administration one, there's resources that are broken up into different sections too. Obviously patient, so you can get all that patient demographic information. Infrastructure, there's a whole tier for that as well, because it's important to be able to share that information in terms of the lists and the basic information about that, as well as financial claims. Obviously, financial information is important to be able to share about patients too. And by bundling different resources together, we create that story for a FHIR message. And what is the anatomy of a FHIR message? I'm going to start from the bottom up. At the bottom, you've got the defined structure data, so that's going to be the information that you're conveying electronically in a computer-readable format, meaning it's either going to be XML or JSON. Above that, you've got your extensions layer, so are we sending any information that isn't defined by the resource spec? If we are, then we're going to send an extension. It's going to have a URL out explaining what that extension is. And then at the top, we're going to have that narrative text. That narrative text is the human-readable portion of it where you're able to actually read it. That's the base level of interoperability. And then there's metadata that's involved with it as well, you know, transmission time, that kind of thing. This is a very familiar-looking message. This is the one that everybody seems to use. But the idea is at the bottom, you've got that computer-readable information. This one's in simple XML. So at the top, you can see that we've got a renal extension, so it's another piece of information we're trying to convey that's not actually defined by that spec. And then we've got the human-readable summary. At the top, you've got the metadata. We can see that it was last updated at that time. But the point is, anybody who looks at this message can clearly understand what is the point of this message? Well, we're just conveying some information about Henry Levin. We can see his date of birth, his gender, that kind of information, his MRN. And then the computers, the end systems that are going to make this all interoperable are able to basically parse out the information that they care about through the tags in the bottom portion. Here's another diagram I have here on the structure of a resource. Same thing, folks. It's got metadata, it's got the human readable narrative, it's got extensions within their elements that have the computer readable portions of it. This is a graphic I really like here, and it's all about combining resources. The idea is when we want to share some meaningful data with a different user, a different system, let's tell more than just the patient was admitted. Let's tell a story here. It comes back where we've got a diagnostic report. So that's the first resource piece of information we're conveying. And that diagnostic report is about a patient. So let's combine that patient resource into it. And that patient is part of an organization, and that diagnostic report contains an observation. These are all separate resources, right? That diagnostic report was prepared by a practitioner. And the important thing here is that every single one of these could exist out in different repositories. These pieces of information don't have to be centrally located. We're not mandating that you have to have that kind of model. The idea is that let's build a story and we'll pull the pieces of information that we want to convey from wherever it lives, and those resources are well defined in those repositories. Just another diagram that we have here. This is references between resources. We can see that the procedure is connected to the condition by the related item. I like to think of it kind of in SQL, the way that you can link different tables, but the idea is that we're connecting different resources together. We're building a story, same kind of idea. Is there a question?
Yes, please. So in terms of accessing the resources where the data lives, even if you write all of this, and it seems like there's plenty of capability to do it. Let's say I want something from Orion, or I want something from
Right.
All right. So what permissions or what do I need to actually? I say I can do it technically, but are there policies or other ways that I would have to work through to get permission to use that data?
Yeah.
In this process?
Yeah, so they're all going to exist in their repositories, right? They're going to be FHIR servers. I'll talk about the permissions, but every one of them can implement it in the way that they see fit. It's going to be their security policy, but every single FHIR entity is going to, and I'll talk about this later, they will publish a conformance statement saying this is the way that you need to authenticate, this is the way that you can access the data, these are the different types of data that I'm going to be conforming to, et cetera. In my sample interface that we actually will go to here in a minute, in my interface engine, I can show you the security that I did as well. No problem. Were there other questions? I'll talk real quick about APIs and then we'll get into the actual example, which I am assuming people probably want to see something real. The idea with APIs is going to be real-time interaction. It's between different systems. It can be from different people. We're not trying to constrain the different number of entities that can connect out to that data. Let's publish APIs where folks can connect and pull that data in any way that they see fit, and REST is obviously one of the API transmission protocols. FHIR is completely conformant with the open API strategy. Obviously, it's being used in Twitter, Facebook. That's how they build all the different little applications and add-ons within it. And it's one of the selling points for FHIR. It actually aligns really well with the Meaningful Use 3 guidelines that they're pulling out about having everything be open API. Transmission protocols, HTTP. A couple of things that you need to send are headers, status codes, the single resource operations. So HTTP is basically the simplest version of web servicing as a transmission protocol, how I'm going to send and receive messages. And you'll have a couple of operations, like I want to be able to read data, or I want to be able to update or delete information. And that's really, really well defined by RESTful web services. You can do searches, et cetera. It's versioned. And then operations are if you want to start doing things a little bit more advanced. Instead of me just wanting to be able to read information for a patient, maybe I want to update different types of patients on different types of criteria. You're able to go ahead and create your own types of procedures, meaning your own types of custom operations. And these, you define your inputs and outputs. And for example, a fetch patient record could be its own kind of specific one. We'll have different types of inputs, give you a different type of output than what you would have gotten with a read call, for example. And it's still going to use HTTP as the transmission protocol. Any questions, or should we jump into the demo? They're going to be the ones that have to tell you how that happens. There already are quite a few of them. I can share with you a couple of FHIR servers where you can interact with resources, and HL7 has them out there too for testing, but it's up to them how they want to go ahead and share that information. All right. Let's see if this, oh, good. So what I'm going to pull up here is, and this is not a sales pitch, folks. This is Rhapsody integration engine. This is our engine at Orion Health, and we are FHIR conformant. And what I want to do is just show you two sides of it, and this is an actual implementation that we built in Connectathon. The idea here is I'm going to tell you the workflow of what I think is going to be one of the more early kind of FHIR implementations. And then I'll show you how the message actually traversed through and how things changed. But what we're looking at here is a development environment. This is where you're going to actually define the flow of how your messages are going to flow from in to out. And I actually have multiple flows on this one interface. The idea here is that you're going to receive a result message, and let's say it's a V2 result message from a lab system. This is standard. This is happening today. It's going to happen via TCP. This is what's going to happen. And what you want to be able to do is receive this V2 message, this V2 result message, and do an EMPI check. Make sure that the patient is the correct patient, exists in your FHIR server. And then once you have that, go ahead and add that information to the resource for that patient within the FHIR server. By doing this, you're going to have to go ahead and transform from a V2 message to a FHIR standard, and you're going to have to go ahead and also send these operations electronically using RESTful web services. So the way it works is we receive an ORU HL7, a result message via TCP, and we can go ahead and use a communication point, an outbound communication point, to perform a lookup. So within that one, we have our own web services. If we look at the web services that I've actually set up here, we can see that under the REST clients, you can define what the port is, what the relative URL is. You can set up security, so it can be HTTPS. So your question earlier about how you can authenticate, you can set up username authentication. They can do it through security, keys, etc., certificates, all that's doable. But in this case, I'm just connecting out to a sample FHIR server, a FHIR repository that Orion has propped up for us to be able to go ahead and do exchanges. And all I'm going to do is I'm going to go check, does the patient exist? If the patient does exist, good. Let's go ahead and convert that result message, that V2 message, into a FHIR message. So what you see here, these little icons in the middle, that's actually where you're able to make manipulations on the message. So we have what are called filters. This specific filter is going to take a result message and map it to a FHIR message. So I'll just show you. I'm not going to get into the nuts and bolts. We're not selling Rhapsody, but you can see that on the inbound it came in as a V2 message. So for those of you that are familiar with a V2 message, we can see that all the information is housed in segments. So each line is a segment. And then each pipe, in between each pipe, is called a field, and that houses some kind of information about the patient. So we can see that this patient's name is Sam Blogs Terry, and that exists in the PID segment. But we've mapped this into a simple XML format where we can see now within that we've got a patient resource. And then we've put in the tags that the last name is Blogs, the first name is Sam, kind of thing. So you can use one filter to very quickly be able to map. And whatever integration engine, or if you're doing point-to-point, you're going to have to do this kind of exchange where you're going to be able to map from what the industry is using today, which is V2, to FHIR compliant messaging. So once we have the message in the correct standard, we go ahead and just send it out to the FHIR resource. So send it out to that FHIR server. That FHIR server will go ahead and respond back either with a successful or a failed addition into that repository. And it'll respond back, and it should respond back in the same syntax that you sent it. So I sent it an XML message. It should reply with an XML message. But we already talked about we need to be able to actually interact with JSON too. So we have a filter as well that's able to format from XML to JSON or vice versa. So just to do that, we can take the response back. I'll show you what it looks like. We get a successful response back, and then this is what a JSON JavaScript nomenclature looks like, where you can see the resource type, and then they're just kind of separated by commas. So you can see that you should be able to interact with not only XML, but also JSON in whichever way you decide to implement these. So I just went ahead and converted it back to JSON. Any questions about the flow? Does that kind of make sense of how that sample interface would work? Why we want to go into FHIR?
I'm a little confused. You know, you said you're creating this resource in the FHIR repository.
Mm-hmm.
So when I think of the workflow, I want to get that lab result in my own data repository, my data warehouse, and so forth.
Yep.
I'm a little confused about is the, you know, how that happens, I guess. Mm-hmm. And is that later, farther down the pike?
Yeah, I mean, that part should be obfuscated from you because it's not something you need to worry about. You need to just be able to share it. In terms of if you want to hold and host your own FHIR server, then from that point you can do whatever you'd like, right? We can parse the information out because we're using an interface engine, and if you want to perform analytics or whatever you're looking to do, you can pull that information that you're looking and house it in your own data repository. But you do have to have a FHIR conformant repository, a FHIR server is what they call it, that is able to house all the resources in the FHIR standard. It's just one way of looking at it. The point is, if you're going to do FHIR exchange, you need to follow the FHIR nomenclature, documentation, et cetera. But they're not going to restrict you from doing anything else that you want to do in terms of picking and peeling the pieces of information that you're interested in capturing yourself too. That answer your question? Sure.
Just take it one step further for a clinician. If a clinician was able to get an HL7 message result in their direct messaging, and they're not sure whether or not they want to pull it into their actual clinical EHR. They want to take a look at it first, or it may be for consultation purpose, whatever. Is there a way of doing an applet where the FHIR could convert that HL7 message as kind of a link in, where in the direct message they could click on the HL7 message, run it through that converter so you get the XML code so that you could display it in your web browser and take a look at it and then decide later what you want to do with it?
Yeah, I mean, I think we're kind of getting into semantics of what the capabilities of your specific interface engine are. With Rhapsody, you could absolutely do that. But I think the goal is, just like you weren't with V2, you weren't going to examine every message before you put it into the EMR. You want it to be interoperable in real time. You probably want it to set that up to be real time too. Maybe you have your own specific reasons or rationale for that, or a very specific use case. But most interface engines should be able to do something like that, where it's housed and it waits for a user intervention before it actually gets populated. Sure.
I'm going to start with a problem statement. I've been working with CDA documents for about 1.5 years now, and
God bless you.
I've mainly been working with quality reporting documents, but some CCDs. And one disservice I have seen done with that is that we go to painstaking detail to make sure that everything is tagged correctly and coded correctly, but there was no standard for what goes into the human readable section. For example, in quality reporting, if a medication is prescribed, the human readable could say what the medication was. It could say what the medication was and the dosage. It could say the medication, the dosage, and it doesn't. There's no standard for what goes into the human readable part. But when I log into my personal health record with my health system, they just show me the human readable. And when we're working with a use case where CCDs are being exchanged from different health systems and going to the primary care physician, they're just looking at the human readable. So has FHIR done anything to say what goes into the human readable part?
Yeah, so I guess with your CDAs, the human readable portion is really going to be dependent on which style sheet they decide to wrap around it, and there's not an agreed standard, you're right. In terms of what the FHIR human readable standard is, I don't believe there is, but it's a good question. If you want to reach out to me after, when we get a break, I'll give you my card and I can take that to the board and see what their response is. I don't believe there is. I think it's just, it needs to be something that people can read and understand. Yes.
Hi. So the provider's ongoing complaints about the $10,000 interfaces. How does, it seems with FHIR you are building a point-to-point interface. Does this address their concern / complaint about, point-to-point interfaces just being too many and too much?
Well, if you're paying $10,000, talk to me afterwards and we can figure something out. But the point is that you focus on the 20% that's tough, which is workflow. And the things that you get bogged down a lot of times with V2 interfacing is, first thing you do is you exchange a spec, and downstream system says, I have all these Z segments and I'm not conforming to V2. So now we have to spend hours upon hours of actually making sure that we speak the same language so we can align the messaging correctly. That is totally done away with FHIR. The second part is, oh, we have to figure out how we're going to do communication. Maybe they want a flat file drop, or maybe they want a TCP, or maybe they're trying to be forward thinking and doing a web service. It's typically TCP, but they could be doing it anyway. Maybe they want an FTP drop. The point is, we don't allow for all those different kinds of options. We standardize along what's working in different industries, which is RESTful web services. So you solve two of the main pieces, which are making sure we speak the same language and making sure that we communicate the same way. And then it's just really focused on, you know, your specific business case. If there's any kind of strange flow, like the one example we had there, if somebody wanted to interrogate it for. And I think that we're looking at, you know, real substantial savings in terms of manpower time per interface. I think, did this help? Is it good to actually see something? I can show you the flow of it actually going through the entire stage if you're interested. Let's just take a look at that real quick. This is the web management console. This is where you can see how messages have flowed through. And I don't know how well that displays up there, but this will just go ahead and trace what happened here. The message came in as V2. We performed an EMPI. The patient was found. We went ahead and did a conversion, and then we wrote it into the FHIR server. So the way it looks here is there's my inbound message. I can look at the next message that came back, which is my response on my EMPI call, and we can see that under my metadata here, I had a 200 search status code, meaning the patient was found, so we actually had it. So we decided, let's go ahead and convert from that result message to that FHIR message now. I can compare in and out. The message came in as an ORU. It was sent out as a simple XML message. I can go ahead and I can see the response that was received back. I can see that, okay, the message was sent out, we got a response back. I could go look at the response if I wanted to as well. And then from there, I can go ahead and see where we converted that response from XML to JSON. This is just one type of flow that's possible. I think it's probably a pretty common type of scenario for people that first want to step into FHIR. So it is real, people. It exists. I know that it's a lot of pie in the sky right now, but people are starting to implement, as you can see from around the room. And this is an actual implementation that we did. Okay, I have a few more slides unless anybody has questions, and I think I have about 15 minutes left. Sure.
So you mentioned this is a national implementation. Could you describe the most advanced implementation of FHIR that you're aware of? What, you know, who or what is out there that is the furthest along in production usage of FHIR, if anyone?
Yeah, I'm probably the wrong person to ask. I think we might want to save that for the following presentations, because I think some of them are actually going into their own, and they may very well be the most advanced implementation in there. It really hasn't taken off very far yet, right? We're still in draft. So I don't see a lot of actual production interfaces happening at this moment. In fact, we just released FHIR Conformance at HIMSS, and that was the first time FHIR was actually talked about on a wide stage anywhere in the States. So I'm not seeing it live anywhere, but that's why I'm very interested to see the following discussions to see what is out there. Sure.
Okay, my question is, do you have an example of, you know, we're talking about the HL7 messages and you showing a couple of HL7s and the different segments in there with the OBX and
Sure.
results and everything. So in my mind, I'm looking at this going, and we're talking about the CDAs. How far has that CDA been broken down where it categorizes all the resources, as you call them, in that message so that you can get to it quickly and the order that the standard says that it should show up, because a provider, they have specific pieces of that information they'd like to see right away and just tab to it, and then they would like to see the most recent and then go backwards in time, but they'd like to see the full history. And do you have an example of that?
I don't have an example of that, but obviously the CDA is more complex than the V2, right? And you're going to have to, unless you have a really great development team, you're going to have an advanced engine that's capable of parsing that accurately. And then you want to be able to see the longitudinal view of the history of the patient. I think that is probably more on the side of whatever your HIE or EMR system is and how it's going to parse it and display that information too. It's all about the functionality, the capabilities of whatever interface engine you're using. If you want to talk more about it offline, we could have a discussion, but I don't have an example right here. I do have sample CDAs and CCDs, but I'm not selling Rhapsody at this moment. Sure, one last question, we'll finish up the slides.
When you bring up Rhapsody, I was noting a strikingly similar interface to Rhapsody. Do you place any sort of restrictions on COM points or anything like that?
Do I?
I mean, does FHIR?
Does FHIR?
Yes.
Guess I'm not understanding the question. Does FHIR place a restriction on COM points?
Perhaps I don't have a perfect understanding of it just yet, but I assume it receives messages as well as sends messages.
Yeah.
Now, I know in Rhapsody there was more of a restriction in the sense that if you wanted to place separate COM points, you do have to pay a higher fee for licensing. Now, in my understanding of this, I assume you can set up COM points and you can set up flows in just the same way.
Yeah, and I'm not going to speak to the licensing model of other competition. With Orion, the way it works is you pay by the number of connections that you want to have, and there's different tiers for that kind of thing too. But yes, if you need to connect out to a FHIR server via RESTful web service, that's a connection. And I think that a lot of the competition kind of has a similar model too.
Okay, fair enough.
All right, so I'm just going to finish up the slides here. Okay, there we are. So we just went through the demo. If it sounds like people are actually interested and have questions, feel free to reach out to me during the break, whatever, and we can have a chat and I can give you my card. A couple of the paradigms I just want to rehash with FHIR is the paradigm for the interoperability is we do both messaging and document exchange, right? It's the best of both V2 and V3. We use web services and we do the simple operations via REST, and then we can do more advanced operations using HTTP, and you can define your own operations as services. Regardless of the content or of the paradigm, the content is the same. You have a FHIR repository. You don't really care where it's coming from. It can come from a lab system as a FHIR message sending you resources. It could come straight off of a tablet. It doesn't matter who the consuming applications are, whether it's going to be off of a server or off of a tablet. Your FHIR repository can combine all those resources together, generate FHIR documents, and you can exchange it with whoever you like, whether it's the national exchange, package it all, create a summary document, etc. A couple little details I'll get into with profiling in FHIR. You're actually able to get into the resources and define more granularly what all the elements are. So you could go ahead, and this is a patient resource, for example. You could specify the number of repeats, whether it's one. You can say whether it's required or not. You can set different value set codes if you'd like to. You can go ahead and set what type of data it could be. It could be Boolean, it could be integer, etc. You could say whether or not something is supported, add extensions directly into it. There's hardly any mandatory elements in each of the resources, and that's important because we're trying to achieve interoperability, and if you start making things more mandatory, then you have more chances for somebody to send you a non-compliant message and you've just failed. So that's kind of the idea with resources. And then the case for extensions, I know we feel like we beat this one pretty good, but I'll say it one more time. You know, you could have two exchanging bodies sending you ZSB segments. You can see there's multiple fields within that ZSB segment. We don't know what ZSB segment means. And even if we did, both of those two exchanging parties could be implementing it completely different. That first field, which is 200.80, that could be an MRN versus the other one, it could be a timestamp. You have no way of knowing with version 2. Within CDA and V3, you have to have foreign namespaces. They can break schemas. It's still a big problem. And then you still need to find that documentation. With FHIR, it's going to be a lot simpler. You just have a regular extension. That extension is a tag. That tag has information pointing to a URL that explains what that extension, how it's implemented. There is one other type of extension called a modifier extension. Please try and not use it when you get into this, because that actually changes the profile. And in fact, you can actually make that make them mandatory values, and that defeats the purpose of interoperability. So if you're going to use extensions, just use regular extensions. Don't make them mandatory. Therefore, you can achieve interoperability. And you can also render those in human readable format. The idea is that within your resource, you've got an extension. It has a URL which points to a profile. That profile will easily explain what the extension does, what the format is, what all of the information it conveys is, etc. My last slide here is on conformance. I talked earlier about every entity that wants to exchange with FHIR, be a FHIR server repository, has to publish a conformance statement. Basically, it's a resource for documenting everything about that entity. So you can say, this is how we're going to go ahead and be discoverable. This is all the information about us. And it's, what are the capabilities of my system? These are the resources I'm implementing. Here's the fields within each of those resources I'm implementing, et cetera. And it tells you the desired set of behavior of what they're trying to achieve. So to be FHIR conformant, you must publish this instance. And my last point is, if you want to start with FHIR, go ahead and complete a FHIR drill. I set up just a very quick checklist of things that you should look at before you even really start thinking about creating a FHIR interface. It's on the Orion Health blog, but I'm not plugging Orion, so I'm plugging myself. You can go onto LinkedIn and find me, and then look at my publications, and go ahead and just pronounce a very quick checklist. It's a good starting point. And that's all I have for today.